Sulekha Sharma and you are watching fourth part of chapter Current Electricity. In the previous class, we have derived the formula for drift velocity. What is that formula? Drift velocity Vd equal to minus E tau by m. This is the formula for drift velocity. And due to this drift velocity inside the conductor, what happens? Current is produced. So today we will derive the relation between current and that drift velocity. Okay. So let us start. First, consider a conductor of length L. Suppose this is length L of the conductor and area of this cross section of the conductor. This is the cross section. Okay. Cross section of conductor. This is the area of cross section of conductor. And then a battery is connected to this conductor. Battery is connected means potential difference is applied across the ends of the conductor. This is positive terminal, so this end becomes positive. Negative terminal is connected to this side, this end becomes negative. And potential difference is applied across these ends of the conductor. Suppose V is the potential difference across these ends. Okay. And due to this potential difference, what happens? Electric field is set up. And electric field is always from positive to negative direction. So suppose this is direction for electric field. Okay. So electrons are moving towards this side. When electric field is applied, electron is moving towards the positive sides of the conductor with velocity what? Suppose Vd. Vd is the drift velocity of electron and all electrons are moving towards the positive end. So let us suppose that first let n be the total number of electrons per unit volume. Per unit volume. In a particular volume, how many number of electrons are there? This is also called, you can say, number density. Number density. Okay. And volume of this conductor is what? Area is the area of A is the area of cross section of this conductor and L is the length of the conductor. So volume of this conductor is what? A into L. And N is number of electrons per unit volume. So total number of electrons becomes total number of electrons inside the conductors becomes what? N is the number of electrons per unit volume. So N into volume, and volume is what? Area into length. So N A L. This is the expression for total number of electrons. Then if this is total number of electrons, then what is the total charge of this total number of electrons? The charge on total number of electrons. What is the formula for charge? You know that Q equal to what? Suppose N is the number of electrons and E is the charge of electron. This total number of electrons is suppose capital N. And if charge on total number of electrons, Q equal to NE. N is the total number of electrons and E is the charge of one electron. So this Q equal to N into E. And N is what? NaL. So this becomes NeAl. This is the total charge on total number of electrons. Now, electric field is set up due to this potential difference. You can write electric field is set up due to potential difference. Okay, and that electric field is given by E equal to what? V by L. Okay, this is the expression for electric field and it is set up due to the potential difference applied across the ends of the conductor with the help of this battery. And due to this electric field, electron starts accelerating towards the positive end of the battery. So what is the time taken by an electron to cross the ends of the conductor? You can write time taken by an electron to cross the conductor. To cross the conductor. What is that? What is the formula for time? Time equal to, yes, you know that time equal to L is the length of the conductor L by Vd. Vd is the drift velocity of electron. You can write there. Vd is what? Drift velocity. Drift velocity of electron. So time taken by an electron to cross the conductor becomes T equal to L by Vd. Now, what is total current? Current inside the conductor. What is the formula for current? I equal to Q by T. And we already know that charge on total electrons is equation 1. This is equation number 1. NE A L. And what is time taken by an electron? This is equation number, this is equation number 2. Time equal to L by Vd. You cancel L. This becomes I equal to NE A Vd. Okay. This is the formula for current in terms of velocity. Or you can say relation between current and drift velocity is I equal to NE A Vd. From this formula, it's clear that I is proportional to what? I is proportional to N, total number of electrons per unit volume, and drift velocity. But drift velocity is very small. So how current is produced if drift velocity is small? Drift velocity is small, but total number of electrons inside this conductor is very large, and each electron experiences drift velocity. So in this way, total current is large. So you can write, even though drift velocity is small, Vd is small, but N is very large, and hence current becomes large. Okay, becomes large. You can write in this way. So I equal to NE A Vd. And you also know the formula for Vd in the previous class. What you have got the formula for Vd, drift velocity? Vd equal to what? Minus E tau by M. So you write current I equal to in this way. This is one formula for current. You can write another way also. NEA. You put the value for Vd. Vd is, this negative sign shows the direction. So no need to put negative sign. Vd is what? E tau by N. So this becomes NE square A E tau by M. And you know what is E? E is V by L. So this becomes N E square A. In place of E, you write V by L. So you write V by L. Okay. So this becomes NE square A V tau by ML. This is I. And from this expression, you can derive Ohm's law. If you take from this equation, you just write V by I. What is V by I? V by I becomes what? If you take I down, then ML by N E square A tau. N E square A tau. So you can write V equal to ML by temperature, you know that these quantities are constant. At fixed temperature T, all these mass of the electron, length of the conductor, number density, charge of electron, all these are fixed. So V is proportional to I. Okay. As the potential across the end of the conductor increases, current inside the current increases. And this is nothing but Ohm's law, which we discuss in the next class about Ohm's law. What is Ohm's law? This is V is proportional to I. And in exams, if questions comes to derive Ohm's law, then you have to explain all these things and you get the final result. V is proportional to I. So we will discuss Ohm's law in the next class. And if relation between current and drift velocity, the main relation is this one, I equal to NE AVD. Remember this formula. VD is minus E tau by M, and current and drift velocity is I equal to NE AVD. And when you put the value of VD, then you get Ohm's law. In this way, Ohm's law you can also derive. Okay, students? So in the next class, we will discuss about Ohm's law, their limitations, about resistance, what is resistance, everything in the next class. Up to then, students. Bye bye. Take care.